For number 8, we're told that the equation of a curve is y equals x to the power 3 plus ax squared plus bx plus 5. The curve has a stationary point at 1, 9, and part A says find the values of the constants a and b. Right? So we know that at stationary point, gradient or dy dx is equal to 0, right? So we're going to try and get dy dx of this. So dy dx equal to 3x squared plus 2ax plus b, right? And at this point, this is equal to 0. So we're going to substitute 1 for x. So it's 1 squared plus 2a times 1 plus b equal to 0. Because dy dx is equal to 0 when x equals to 1. So 3 plus 2a plus b equal to 0, right? Like this. And we also know that this point is on this curve. So we can substitute 1 for x and 9 for y. Right? So doing that, where it says y here, we're putting 9 equal to 1 cubed plus 1 squared, that's a, plus b plus 5. Right? So this will give us 9 minus 1, 8, minus 5, that's 3. So 3 equals a plus b, like that, right? So making a the subject, a will be 3 minus b. So we're going to substitute this for a in this, right? And doing that, we get 3 plus 2, 3 minus b, plus b equals to 0. So 3 plus 6 minus 2b plus b equal to 0, like that. So this will give us minus b, 9 minus b equal to 0, and our b equals 9. And so now from here to get a, we're just going to substitute b into this equation. So a equals 3 minus b, which is minus 9. So our a is minus 6. Right? You get your 5 marks there. Then for part B, it says find the coordinates of the other stationary points. Right? Find the coordinates of the other stationary points. So the gradient was 3x squared plus 2ax plus b. Dy dx was 3x squared plus 2ax plus b. And we know that a is minus 6 and b is 9. So 3x squared plus 2 minus 6x plus b. Right? So 3x squared minus 12x plus 9 should be equal to 0 at stationary point. Right? So for this, we're going to use the quadratic formula. So 12 plus or minus 12 squared minus 4a and c all over 2a, like this. And this will give us x equal to 1 or x equal to 3, right? So for this, we're told one of the stationary points is at 1, 9, right? And this is the 1. And for the 3, we're going to try and find the y coordinate. So we're going to substitute 3 into this equation, right? 3 minus 6, 3 to the power 3 minus 6, 3 squared plus 9, 3 plus 5. Then we get 5. So when x is 3, y equals 5. So the coordinate will be 3, 5. This is the other coordinate of the other stationary point. Right? You do that, you get 3 marks. Then part C now says a point P is moving along part of the curve in such a way that the y coordinate of P is increasing at a constant rate of 6 units per second. So the y coordinate, that's dy dt equals 6. Since they said it's increasing, so 6 is positive. If it had said it's decreasing, we would have written minus 6. But for this case, it's increasing, so it's 6. Then it says find the rate at which the x coordinate of P is increasing when x equals 5. So we're being asked to find dx dt, the rate of change of x, right? And looking at this, you can see that we can use dy dx to connect them. So to get dy dx, it's dy over something times that over dx, right? Assuming that this will cross out. So in the box we can put dt, right? This is dy dx, and we will also get dy dx from this side. But now we're connecting these, right? So we're going to try and find dy dx at x equals 5. Then we use this for dy dt. Then we find dx dt. And so our dy dx was 3x squared plus 2ax plus b. 3x squared plus 2ax plus b. So 3x squared minus 12x plus 9. And substituting 5 here, 325 minus 12, 5 plus 9. You get 24. So when x equals 5, dy dx is 24. Right? So 24 equals to dy dt, which is 6 times dt dx. And for us to get dt dx there, we divide both sides by 6. Right? So dt dx is equal to 4. Right? But we want dx dt, not dt dx. So if we have dt dx and we want to get dx dt, we're just going to invert this. Since this is 4 over 1, so it tells us that dx over dt should be 1 over 4 units per second. Right? You get your 3 marks.